A 12-volt battery is connected. Look at the question. First, read the question. A 12-volt battery is connected in series to a 24-watt lamp and to a parallel wire of identical resistors X and Y. The figure 9.1 is the circuit diagram. The 24-watt lamp lights at normal brightness. When the potential difference across it is 6 volt, the lamp is at normal brightness. Calculate the resistance of the lamp. We have one formula, P is equal to VI. We have a formula P is equal to V square upon R. We have a formula P is equal to I square into R. They have given me power. They have given me voltage. And they're asking me to get resistance. So can you point out for me what formula should I take? What formula should I select? Quickly answer, please. Look the letters P, V, R. No response, so I marked it. Remember, a response time is matter. If you do not respond, you're doing something else, you're looking at the mobile, or you're not answering in time, then it's a serious mistake, because past paper means a quick response within the given time.
I asked for a minute. I just came back now.
Look at the screen, please.
I am now. I'm calculating English.
So please look at this calculation and solve for me. Let me have the answer quickly. 1.5. Good. Determine the PD between A and B. He's asking to find the voltage between A and B. A and B means two connection points. X and Y are in parallel. In parallel, voltage is the same. In parallel, voltage is the same. Voltage is 12 volt. So across A and B, the voltage would be 12 volt. The combined resistance of the parallel pair of identical resistors X and Y. So when two resistors are in parallel, when two resistors are in parallel, we use this formula. Actually, then there is an issue. There is a lamp here also. The 12 volt is the lamp. How much resistance is 1.5? Let me first correct. I didn't see the lamp actually. There is a lamp here. So I missed it, and the voltage will not be the same. Look at this. There is a lamp also. 12 volt is the total supply. Let me work out for the step. The 12 volt is the main supply. If 12 volt is the total supply and it is taking 1.5 volt, how much voltage will be left for the A and B position? Total is 12. Total is 12. Lamp takes 1.5. So how much is left for the question mark position? How much is left for the question mark? Shabash, quickly, it's a series circuit. Right. Zainab, it is 10.5. Perfect. Good. Hamad, right. Perfect. 10.5 is coming from 12 and 1.5 subtraction. Two identical resistors are there. 12 volt is the battery. The issue was the error of 1.5. 1.5 is not the voltage, it is the resistance. Now the lamp is taking 6 volt. The lamp is taking 6 volt. So the remaining AB connecting circuit is also taking 6 volt. He's asking the combined resistance of the parallel pair of identical resistors R. So now think of this topic. How should I find the resistance? Examiner says parallel. It's a parallel pair of identical resistors. Now, this is a bit tricky part. I do not know any one of them, but I know 6 volt is coming from the lamp. 6 volt is coming for the lamp, and X and Y are the two resistors separately, but they are in parallel combination. The combined resistance of the parallel pair, I know the voltage, but somehow if I can get the current, I can use Ohm's law. Can you help me to find the current in this circuit? How can I find the current in the lamp? Any formula? I know the resistance of the lamp. I know the voltage on the lamp. So how I can find the current in the lamp? This is the data. So can you help me how I can find the current? Help me find the current, please. Now do this calculation. The PD across A and B is 6 volt. So I will use the 6 volt and I will get the current. Hmm, 1.5 as it should be. So the resistance of AB, total resistance of AB is also 1.5 because when voltage is the same, they both have 6 volt, the resistance should also be the same. He says find the resistance of X. They are identical resistors. They are identical resistor. Identical resistors mean identical resistor means that they both have the same value. Identical resistors mean that they have the same value. So I can take both of them as R. I can take both of them as R because they are identical resistors. So in case of identical resistors, you have the value 1.5. So this is the value of the resistor. One resistor in the pair. Now look at the next part. Resistor X is removed from the circuit. Why the lamp becomes dimmer? So if you remove resistor X, only resistor Y is there. In parallel, resistance decreases. In parallel, resistance decreases. When you remove Y, when you remove Y, the resistance of that position increases. Let me draw the circuit again, and you should draw with me so you can understand that what happened. I have removed resistor X. Look at this circuit now. It is only resistor. It is only resistor Y, only one resistor. Lamp is dimmer. So copy this circuit. He's asking why the lamp is dimmer. Now there is only one resistor. It is not parallel anymore. So resistance increases. When resistance increases, system will get less current. When system gets less current, it will be dimmer. The current in the transmission line used to supply current in the transmission line used to supply electrical power to a village is 65 ampere. The power is transmitted at a voltage of 23,000. Start this question yourself. Start this question, and I'm just coming in a just in 2 3 minutes. I have to say namaz, and meanwhile you can solve this question and you can compare the working from the screen. Solve this question quickly. First answer is 1.5 into 10 power 6. The transmission line has a resistance of 3.0. We show the formula, calculate the working, and three significant figure. The answer is 195 volt. Thermal energy produced in 1 second in a 3 ohm resistor that carries a current is this. So we put the formula, do the calculation, and we got this. State one advantage of transmitting electrical power at a high voltage. This is what topic we haven't done yet. And the second part is also electromagnetic induction. So that's not also part of it. So compare the answers. First, we had defined electromotive force. Then we are doing the second part. 12 minus 3 is 9. Perfect. The figure shows a circuit. The two lamps are identical. Identical means they are having the same configuration. The two lamps are identical. Each lamp has a PD of 3 volt across it and a current of 2 ampere in it. PQ is a length of uniform metal wire. The resistance of PQ is R. Calculate the value of R. We got the voltage. We have the current. So we can use the formula V is equal to IR. R is equal to V upon I. 9 upon 4. So solve this. So quickly solve it. It's simply 9 upon 4. It shouldn't take much time. $2.25. Another piece of wire is made of the same metal as PQ. The length of the new piece of wire is twice the length of PQ. The diameter of the new piece of wire is twice the diameter of PQ. Length is twice. And the diameter is also twice. Calculate the resistance of the new piece of wire. I have written the formula. We have the present resistance. So present resistance is 2.25. Second resistance I have to find. The wire is double. He says twice the length. So if it is L, the new wire is 2L. Be careful here. It is D2 upon D1. So if the new diameter is 2D, it will be compared with D, the previous wire. Now this is the working. Please solve it. I'm solving it. Please solve with me and let me know the answer if you get through this calculation. $1.125. Hamad, what are you getting?
1.1255.
Are you solving or not?
Yeah.
Good. So we keep it up to here, and this is all for today. No problem. So this is all for today, and we will inshallah continue this in our next class. Thank you. Allah Hafiz.